Okay, so now after all of that discussion about addition, let's talk about subtraction, um, which is given a whole lot less time. Okay, so let's go back to maybe pre-algebra, math 8, maybe math 7, I have no idea. So when we're first talking about subtraction, okay, we say 5, take away 2, and we get 3, no big deal. Okay, then we get into negative values. Okay, so let's say 5 minus 12, and then you get negative 7. Now that is no big deal, but actually what you're doing is you're adding a negative. So you're going 5 plus a negative 12, and that gives you that negative 7. So when we think about adding vectors or subtracting vectors, okay, we are actually going to think about adding the negative, okay? Okay, so we think about it like this. If we have u minus v, that is the same thing as saying u plus negative v, like that, with a negative scalar. So v has a scalar of negative 1. Now remember, if you have a negative scalar, it changes the direction of the vector. Okay? All right. Now, another thing to remember about vector subtraction. Okay, vector subtraction is not commutative. So what that means is it means that we cannot change the order. Oops. Okay, so now I'm going to kind of skip the parallelogram rule and all of that. So what we're just going to do is we're going to subtract two vectors. So because I'm going to use them again, we're going to say vector u is negative 4 and negative 10. Vector v is 3 and negative 12. Okay, so we are going to find u minus v, and then we're going to find v minus u. Okay, so if you want to treat it with the scalar multiplication, or you can just do the subtraction. So what you're going to do, horizontal component subtracted first, then vertical components subtracted next. Okay, biggest thing that you guys need to watch out for is your signs. So negative 7, and then negative 10 minus a negative 12 is a positive 2. So watch your signs. Okay, now let's switch it up and prove that it is not commutative. So now we're going to go 3 first, minus a negative 4, then negative 12 minus a negative 10. Okay, so that would be positive 7, and then negative 2. Well, that was interesting. But you can see that the vectors are not the same. Okay, so now let's make it a little bit more complicated. Let's have a little bit more fun. Okay, let's add a third vector. Let's go 10, negative 8. So let's say the problem asked you to do something a little bit more complicated. So let's say you had to find 2 u minus 3v. Okay, well, how would we handle that? Oh, and then just for fun, let's do a plus w. Okay, so I would not draw this out. I would not do parallelogram rule. I would do the numeric method. Okay, so let's do some substitution. So 2, there's vector u, then minus 3, there's vector v, and then plus w. Okay, so same rules apply for distribution and all of that. So this is going to become negative 8, negative 20. Now if you distribute the negative 3 in, this is going to change to an addition. So I'm going to go ahead and distribute that negative 3 in to make it a little bit easier. So negative 9, positive 36, and there's my u, or w, excuse me. All right, so now if I add my 3 vectors together, what we find is we're adding our horizontal components, negative 8, negative 9, positive 10, and then we are adding our vertical components. So negative 20, positive 36, negative 8. So let's see, negative 17 plus 10, negative 7, negative 20 plus 36, that would be plus 16, minus 8 is 8. And there is my final answer. Okay, so the trick with this is don't make it harder than it is, and vectors are usually fairly friendly. Okay, so I hope this was helpful, and we will talk about unit vectors in component form versus linear combination form in our next video.